Welcome to Computer Graphics Adventures. I'm your host, Robert Van Sluten. This channel covers the basics of CG. Let's get started. For the purpose of demonstration and exploration, I've put together an application which runs both on a Mac and an iPhone that currently demonstrates four concepts. There's recursive triangles, there's rosettes, polyspirals, and 2D rotation. Same thing on the iPhone. Now I'll be going into the algorithms and the code in detail. While this is a Mac and an iPhone application, 90% of the code is platform independent. It is written in Swift, but it could be easily transposed into any other language. Let's get started. I want to start by covering the architecture of the application. It creates a fixed size window. It can't be resized. There's a region which is drawn in. Everything that is drawn is lines. There are four high-level functions. Each corresponds to a particular button. Each button push cycles through data that is passed to its corresponding function. Now, in the case of the triangles, an integer is passed. In the case of the polyspirals, there are three floating point numbers. For rosettes, it's an integer. And for the rotation, there's an angle. Now, with the rotation, there is also an array which defines the vertices of the polygon. Each of the four functions generate an array where each element defines a line. Now, the endpoints of the line are defined within a normalized coordinate system. Now, the normalized coordinate system is 1.0 by 1.0 in size. So each point is defined by two floating point numbers. Now, the application coordinate system is the coordinate system of the view area within your application. Now, that depends on the size of the view which you choose. Now, there needs to be a mapping between points in the normalized coordinate system and points in the application coordinate system. There's a 2D world coordinate system, which I'm going to discuss when we get to the rotation function. Let's jump into some code. I have a set of constants. I have pi and I have a conversion factor from degrees to radians. Now, also, you're going to need to define the number of points on an application level of the view that you're drawing in. Now, keep in mind that's a square, so you only have to decide the length of one side. In my case, it's 750 points for Mac OS, and you really don't want to draw right on the edge of that. You want to have a margin, and I'm using 30 points. Now, iOS, that situation is different. I'm using 300 by 300, and I'm making the margin 10. Now, as a result of these two, you have the actual size of the view that lines are drawn in, and that's simply calculated by the defined size in the application minus 2 times the margin. Let's move on. I have a structure named PT2D, which defines a point in normalized space, simply x and y. Now it's got functionality. Now keep in mind this is an object-based design. In other words, data structures have function. I don't use inheritance though, so this is not an object-oriented design. The function returns a point called CG point, which is actually a point in the application view. And that's done by a very simple calculation. Now, the reason there's ifs and if-else for iOS and Mac is because the Mac view, the origin is in the lower left corner, and in iOS it's in the upper left corner. I have a definition of a line, which is simply the 2 points in the line, and I have an array of lines. And this is what the algorithms write into. In other words, the algorithms generate an array, and that array of lines is then drawn. This is a global. It's the only global in my implementation. At the lowest level of the application's implementation, there has to be a mechanism of taking the lines in the lines array and rendering them on the application view. Now, this functionality will have to invoke some API for the particular platform you're on. In the Mac and iOS case, it's Core Graphics. What's shown here is the code for the Mac. It's slightly different for iOS, and you'll see that when you take a look at the code that's available on the website. I'm going to end here, and we continue our discussion in the next video.